Welcome to Lesson 27 of Module 3, where you today are going to be taking a look at some division problems of numbers that have a 3-digit dividend and will be divided by a 1-digit divisor that will be represented not only numerically with numbers, but with place value discs as well. We're going to look at what is the connection between solving standard algorithm and solving with place value discs. So to start us off, we're going to start with the problem 423 divided by 3. So again, I don't have that fancy division sign when I am typing. So that slash, if you ever see that, that just is kind of stepping in for division. But to write it as you would normally see it, we've got the 423, the dividend, under our bracket, and then we've got the 3 on the outside as our divisor, so the number that we're dividing by. So the first thing that we want to do is we want to represent this in the place value chart. So this is something that we have done with smaller numbers. We're now going to look at what this looks like with a little bit larger numbers. So I hope that you're kind of thinking ahead of me right now and you're thinking, okay, what number am I going to start with in the place value chart? So in this case, my dividend, my 423, is what I'm going to place in the place value chart. So I'm thinking about how can I represent 423 over here in the place value chart. So I know that I have 4 hundreds, I have 2 tens to represent my 20, and I have 3 in the ones. Draw my line. Now I'm thinking to myself, how many sections, how many groups am I going to divide this into? Well, I'm dividing by 3, so I know that I'm going to be distributing these place value discs into 3 groups. So I am going to start, we're always going to start with the largest place value in case we have to unbundle, because we cannot have remainders in any place value except for the ones, because I know that if I were to have a remainder in the tens, well, that remainder is not just an equal to 1 or 6, it's equal to 10. And I can always divide up 10 more, or I can always divide up hundreds more than I would be able to divide up a 1. So in this case, I'm going to distribute here. So I have 400. So I've got 100, 200, 300. Cross those off. But I have 1 left over. Now, what do we need to do with this remainder in the hundreds place? Because I can only fill 3 of my groups. Well, I need to decompose this number, or I need to unbundle this number. So I'm going to send it over here to the tens, because it's left over right now. And when I send it to the tens, I know that I don't just send it over as 1, because that's not a 10, that's 100. So in this case, I need to add 10 dots to my tens place, because when I take 100 and unbundle it into tens, I know that there are 10 tens in 100. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I now have 10 tens that I just moved over, in addition to my 2 tens that I already had in there. So right now I have 12 tens that I'm going to be distributing. So I'm going to go ahead, I'm distributing those into 3 groups. So I have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And remember, our goal is to make the groups equal. We don't want to give anybody extra. We don't want anybody to have less than anyone else. So if you cannot make a whole group, then those will become your remainders. But in this case, it worked out perfectly. I used all 12 of my dots in each of my 3 groups, and I ended up with 4 in each group. So I have 100, 4 tens. I'm not done yet though. I've got 3 ones here I've still got to distribute. I didn't have a remainder from the tens, so I don't have to unbundle anything. But I do need to take my 3 ones and place them into my groups. And if I were to have any left over in the ones place, those would become my remainder. But in this case, it worked out perfectly, and I ended up with 1, 1 in each of my groups. So down here in red, 100, because I have 1 place value disc in each of the hundreds place. And the tens, I have 4 tens because I have 4 tens in each of my groups. And 1, 1 because I have 1 place value disc in each of my ones groups. So in this case, if I were to try to figure out what is my quotient for 423 divided by 3, I would say I have 100, 4 tens is equal to 40, and I have 1, 1. So I have 100, 40, plus 1. That's kind of that would be our expanded form of what I've just done over here. And when I add those together, I get 141. Let's check our answer just to be sure. 141 times 3. 3 times 1 is 3. 4 times 3 is 2. Carry the 10 over, because it's 4 times 3 is 12. 3 times 1 is 3, plus 1 is 4. So we checked out perfectly with 423 being our original dividend, the number that we had under our division bracket. We're going to now take a look at another problem very similar to this, only this time along with the solving the problem using the place value chart, we're going to look at how does this match up to solving it with the standard algorithm. So if you think back to when we solved standard algorithm with smaller numbers, we talked about that silly saying of, does McDonald's sell burgers repeatedly? So in this case, we're still thinking about that. That helps us keep our steps organized as we work through. But in this case, I want you to really be paying attention to why does the standard algorithm work the way that it does? Because showing it on the place value chart demonstrates that really nicely. So in this case, I've already prepared my problem. I've rewritten my problem with my division bracket. And the last step I need to do before I begin solving is I've got to place my number in the place value chart. So in this case, I need 7 hundreds, 4, 5, 6, 7, 8 tens, 1, 2, 3, 4, 5, 6, 7, 8, and 3 in the ones to demonstrate or to represent 783. Now, on your whiteboard, I want you to be working through this problem with me. You're going to want to split your whiteboard into 2 sections so that you have one section for the standard algorithm and one section for your place value chart. Or if you'd like a piece of notebook paper to show one and work on your whiteboard for the other, that's fine as well. Alright, so first step here, let me finish setting up. I want to change my color. I want to separate my original number, and in this case I'm going to be dividing by 3, so I need 3 groups. And when I look at this problem to start, I want to divide my 700s, because remember I'm starting with my highest place value, my 700s by 3. So when I do this, 1, 2, 3, 1, 2, 3, I have 1 remaining. Because if I were to put that in a group, my 3 groups would now not be equal, which is I cannot have. I can't give somebody extra. So I can't keep that hundreds in there. So I have 2 hundreds in each group with 100 remaining. In this case, we would say that we have 2 hundreds, 3 times. And I want you to think to yourself, what's a multiplication sentence that would represent that? So if I have 200 3 times, it would be saying 200 times 3. So if I'm thinking about this this in terms of my standard algorithm, then I would say that I divided 7 by 3, or into 3 groups, and I had 2 in each group. And I would say that we started with 7, that's where we've got this right here, 7, and we used 6 of those hundreds. And we have now 100 remaining. So I used my 200s times 3, got me those 600s that we used, with 100 remaining, which I represented with the circled place value disk in the hundreds column. Okay, now we've got to ask ourselves, how many 10s do we have left to be divided? And we have, if we remember back to our original problem, it was 783. So I have 8 10s that are left to be divided. 8 10s. So now, along with our remainder of 100, we have our additional 8 10s. Well, we know that when I have a remainder in the hundreds, I've got to send it over, and that comes over as 10 10s. So I need to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 10s. And if I think about now, how many 10s do I have? I have 18 10s. Alright, I've now got to divide my 18 into my 3 groups. So I've got to be thinking about, first of all, am I making equal groups? And once I've done distributing, do I have any left over? So I've got 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if I think kind of in advance, and I think to myself, okay, I'm dividing 18 into 3 groups, I could have probably guessed ahead of time that I was going to have 6 in each of my groups. So if I think about my standard algorithm, I had 18 10s that I divided by 3 and had 6 in each group. And I used a total of my 18. I used all 18. I didn't have any remainders left. So I would say 18 10s minus 18 10s. I have 0 10s left. What do we have left to distribute is my next question. Well, I have the 1s left that I have not divided yet. And how many 1s do we have? We've got 3 1s left. So I have a 3 that I still need to divide. And when I divide 3 by 3, so 3 divided by 3, that equals 1. So I should have 1 in each group. This checks out perfectly with my place value chart. So when I divide 3 into 3 groups, I have 1 in each group. And we would say that we recorded 1 1 3 times. So 1 1 in each of my groups for 3 different groups. That means that I have used 3 of my original 3. And when I go to see, did I have any remainders here? Well, I used all of them, so no, I did not have a remainder from my 1s column. So in this case, I am showing that 783 divided by 3 is equal to 261. Well, let's look at our place value chart. I had 2 in the hundreds, in each of my hundreds groups. I had 6 in each of my tens groups, and I had 1 in each of my ones groups. So, showing in my place value chart, I'm showing 261. Using my standard algorithm, I'm showing 261, and let's check it out. We've got 261 times 3. 1 times 3 is 3. 3 times 6 is 18. Bring over my 10. 3 times 2 is 6, plus 1 is 7. 783. Excellent. Okay, we are going to now do a very similar problem. We're going to complete it using the place value chart as well as the standard algorithm. So I want you to set up your board again. We want two sections here, one for the standard algorithm, one for the place value chart. And this one, I want you to really take the initiative and complete the steps. You can, if you'd like to, do it ahead of time and then watch the video to see, kind of match up to see if you have the same thoughts that I do. You can absolutely do that. But I do want you to be working on, can you complete the problem in the place value chart, and how does that match the steps that you're doing in the standard algorithm? Because on your problem set today, you will be completing both pieces to each of your problems. So on this one, again, I want to start with my numbers in the place value chart. So I need 546, 3, 4, 5, 6. And I'm going to separate with, I'm divided by 3, so I need 3 groups. Perfect. And in this case, I am going to start in my hundreds column. So I have 5 hundreds. And when I divide 5 hundreds by 3 into 3 groups, I end up with 100 in each of my groups. And then I would say that I recorded 100 3 times, which gives me 3. I used 3 of my original 5 with 2 left over. I have 2 hundreds left over. Okay, I'm done with my hundreds column. If I look at my tens column, I've got to ask, well, how many tens remain here? I have 4 tens that remain, but I don't really just have 4 tens that remain, because I have to bring my hundreds over. I've got to unbundle these. And when I unbundle those 2 hundreds, I know that I have 10 in each of them, 10 tens in each. I bring over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I bring over 20. So I actually have 24 tens. And when I divide those 24 tens into 3 groups, well, if I think about my math fact, 24 divided by 3, I know I'm going to have 8 in each group. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if that didn't come to you right off the bat, then absolutely go through and cross out each of your tens until they've all been distributed into one of your 3 groups. But in this case, this is just a good way for me to check, am I going to have any left over? And in this case, no, I'm not going to have any left over. But if I am looking at my standard algorithm, well, I divided 24 into 3 groups, and I had 8 in each group. And of those 24, I had 3 groups of 8, and I used all 24 of my tens, which left me with no remainder. But I still have 6 in the ones that I have to distribute. So if I distribute 6 ones, before I do that, 6 ones divided into 3 groups, I should end up with 2 in each group. So let's check here. And there we go. I've got 2 in each group with no remainder. So of my 6 ones that I divided by 3, I have 2 in each group. And I used, with 2 in each group and 3 groups, I used all 6 of my ones and ended up with no remainder. If I'm looking at my final outcome here, I ended up with 1 in each 100 group, 8 in each 10 group, and 2 in each 1 group, with a quotient of 182. And if you notice up here on my standard algorithm, I match with the answer of 182. So let's check this. I have 182 times my divisor 3. 3 times 2 is 6. 3 times 8 is 24. 3 times 1 is 3. Plus 2 is 5. So if we're thinking about how is this problem different than the last problem that we did, you might be thinking, well, I ended up having to actually decompose 2 hundreds this time rather than just one. So I ended up bringing over 20 tens with a total of 24 rather than just bringing over 10 tens like last time. As you work on your problem set today, it's going to ask you to not only complete the place value chart, but complete the place value chart alongside the standard algorithm. So as you're working, make sure that your steps are lining up because the standard algorithm is very closely related with the place value chart as we saw in the video today. If you need to come back to the video to watch a model of how it worked or revisit any parts of it, always do that. That's a great resource for you to use as you are then working independently on your own.